Whoa, what the? I'm pressing the stop button, holding it, release. Okay, well, first question, first rule, what's changed?
All right, before we actually get into this, full disclosure, I want to be straight with you. We had an issue with the 80-8, and I can't help you if I don't put all my cards on the table. The deck was stuck in rewind. And I'm saying that up front because this episode isn't one of those neat fixes where you swap apart and move on and you get to watch. I chased my tail on this one.
Welcome to the bane of your existence. Oh God. This is the logic board for it.
First thing I notice that all the IC chips are in sockets.
Yes, that is a known issue.
Maybe it is an issue, but I don't see it as an issue. My point is that it makes it real easy to pop the chip out and put another one in there.
But it also has room for corrosion and poor contact.
Now, just because our machine was stuck in rewind doesn't mean that's the only way this kind of problem shows up. If your machine gets stuck in, say, fast forward or play or pause, even stop, you could be dealing with the same type of issue just showing up in a different way. At the end of the day, these are all logic states. They're interlocked to keep the machine from self-destruction or hurting the tape. So when the logic misbehaves, the deck gets stuck, and where it gets stuck depends on where the failure is. So even though you're going to hear us talk a lot about rewind in this episode, that's just where our problem showed up. The troubleshooting still applies. Same symptoms, different problem. And the reasons this gets complicated were layered. 50% was due to design, 50% was age, and 50% was me jumping to conclusions. There are times when preventive maintenance can introduce a new problem on something this old. And this episode is a really good example of that. So what we're going to do is walk you through the entire path we took because there's a good chance you might run into something very similar. This episode took months for a reason. So let's get into it. Well, what's changed? I mean, I replaced LEDs and I reseated the ICs. Did I make more work for myself? I think the answer is duh. And I didn't pull the ICs all the way out. I just sort of walked them out a little bit and pushed them back in. So that should not have created a problem. Operative verb being not. See the buttons here, user interface, is actually a circuit board which is connected to the circuit board here through this edge connector. But that I never removed, so something in the communication is not getting there. I'm going to start checking for what I may have contributed to this shortcoming. I'm going to start up here. This is IC 1, 2, 3, 4, 5. Tell you what, these pins are really, I don't know what, oxidized? I have to wonder if they're making good contact because they're virtually black. So you've got these pins that are going into little sockets for each of the legs of the IC chip, and this one here, pin 1 of what I believe is IC 24, rather than being right into the socket itself, it was actually here, and this, I could see this part of it just sort of sticking up, so it sort of jumped out at me. So if there's oxidation on this leg of the IC chip and it's not making good contact, then that could have contributed to the problem. All right. If the pin is actually inside the socket, then you have a better chance that it's going to either make contact on this part or on this part. So that may be it. Just a visual inspection, that's the only thing out of all of these that's jumped out at me. Before we go any further, there's something really important I want to point out, because this is where you can make more work for yourself if you're not careful. Anytime you're reseating ICs, you need to be absolutely sure every pin is actually going where it's supposed to. And I mean every pin. In this case, I didn't pull the chips all the way out at first. I just sort of walked them out a little and then pushed them back in. In theory, that shouldn't create a problem. In theory. What I eventually found was a pin that looked fine at a glance, but wasn't actually seated. It was just close enough to fool me, and that's all it takes. And when you're dealing with a logic board like this, you end up pulling it, changing something, reinstalling it, and hoping you fixed it. Pull it, change it, reinstall it, fixed? Nope. Rinse and repeat. You fight with it. You think it's seated. You hope it's seated. And in that process, you can accidentally introduce a brand new problem that didn't exist before. So if you're following along at home, this is one of those moments where you slow way down. Actually verify every pin. Because from this point forward, things start getting weird. And if you don't know whether you created a new problem or, hello, uncovered an old one, it gets confusing fast. Ask me how I know. You know, IC sockets are meant to facilitate replacing chips. When the manufacturer incorporates IC sockets onto a circuit board, they expect at some point chips going to have to be replaced, and they wanted to make it easy-ish in order to accomplish that, so they actually put sockets on the board. That should be a tell. It's just one of those things that occurs to me. Now I could do one of two things. I could go ahead and put this chassis back in, wire it all up, and see if that particular fix took care of the problem. Or I could just one at a time pull each chip, clean oxide off of all of the legs of each chip, then put it back in and see if the problem still exists. But I really don't know what fixed the problem. In my heart of hearts, I want to know what took care of the problem, because otherwise I still have a mystery and it's going to just stick in my craw as far as, you know, what took care of the problem. Problem's not fixed. I just wanted to reseat them one more time, see if that solves anything. It's a little disheartening. Now it's personal. It also seems vaguely familiar, does it not? I've been here before. A little bit of that Vujade feeling. Yeah, Vujade, man, that's that mysterious feeling in your pit of your stomach that you've never done any of this before. Ooh, I got goose pimples. Pause button's blinking. That's a good thing. It quits that after a while. Now, the piece of resistance, as opposed to excessive capacitance. Raise this up. And it's doing it again. Man. It was working. And then after doing the LEDs, I figured, okay, I'm just going to reseat all the IC chips. Then it had a problem. That problem. So in checking out the logic and all, felt like I was going to say something else. I don't even know if I can describe it at this point, because I am so thoroughly pissed off. Okay, when that happens, time to walk away for a little while, maybe grab a cup of coffee, and think this through. It had to have been a logic issue, but here's what I did discover. And in looking at the schematic, the rewind command, if you will, right here, this point right here is pin 11 of IC1. And it was behaving. Press the switch, release the switch, and it was registering fine. And then going so far as to check pin 8. The switch was not seized up, yet it was still stuck in rewind mode. I got to IC4 right here, and it's behaving. It's just an inverter. It was still behaving in such a way that it shouldn't have been locking it into the rewind mode. All this stuff right here, okay, it's taking the switch, the rewind switch, and because it's an electromechanical switch, they're using the TTL logic to create a clean pulse with a high slew rate in order to clean that up to make sure that it doesn't detect, for example, 2 button pushes. If it's just making a little bit of a contact or you don't hit it just right, and it actually sends out 2 pulses, that circuit right there is going to prevent that from seeing 2 button pushes. This section right here is IC14 and IC15. So the rewind command, if you will, is going to be arriving in this section right here for the rewind mode. Now, right above this, up here in fast forward, that is actually part of or half of this whole dual circuit, if you will. And these are tied together for fast forward and for rewind. So if you hit the fast forward while it's rewinding, it will reverse and go into fast forward mode, which would help you slow the tape down, take a little bit of strain off of the tape and so forth. So I get it. That's what they're trying to do. And they're basically what is called interlock. So you can go back and forth between modes. And what I discovered in using the probe to go through and identify where the problem could be, as far as something not changing state because it was stuck in rewind, something must be locked up. Well, the circuit for fast forward worked just fine, okay? So long as I could get it out of the rewind mode. But I could take the measurements and actually determine that pressing the fast forward button was causing that to react to it, which would actually switch the interlock to fast forward mode. But because it was locked into rewind, it wasn't going to be able to do that. The moment I put a probe onto pin 6 of IC15, the moment I touched the IC chip, I hadn't even made good contact with pin 6 yet, the whole thing started to behave itself. Took the probe away and the problem resumed. I mean, I had already gone through and reseated all of those. Well, there's just a whole bunch that needs to be gone through, and this is not a cosmetic treatment here. This is preventive maintenance. Well, it's working, and it escapes me as to exactly why, but with the arm held in position, it's not rushing into rewind mode. Works fine. In fact, that hesitation right there where you saw it stop on its own is part of what clued me in on why it started working. So while it was actually doing that, stuck in the rewind mode, all I did was hit the tape counter and zeroed out the counter, and it stopped. And it's been fine ever since. So, rule number 17, if it ain't broke, don't fix it, moving on. But it wasn't fixed. Not really. At the onset, it looked like I was done with it, so I signed off on the machine. After all, it was stress tested and it was working, so it went into service. We recorded demos, gigs, and performed mixdowns, and it behaved, for the most part. But it was giving us indications the whole time, if only I was paying closer attention. So let me walk you through what actually happened, in the actual order, because a lot happened leading up to this episode. Early on, I did some basic cosmetic work. I replaced LEDs and changed resistors to compensate for the new current limiting. But now the deck was stuck in rewind.
Whoa, what the?
So I started reseating chips.
All these IC chips that are in here, so I just want to loosen them up a little bit and then reseat them.
I found a pin on one of those ICs that wasn't aligned properly. So once it was aligned, I tried testing the board by installing it. No joy. And that's where you start asking the scary questions.
Did I make more work for myself?
Because at that point, I was in rinse and repeat territory. reseating chips again, reinstalling them again. Still no joy. So I switched tactics. One at a time, I pulled each chip, cleaned the pins, and put it back. No socket spray, just cleaning the pins. And no joy. And I slurred that. And still no joy. And there was a lot of temptation to make wild assumptions. Maybe the tape counter reset is involved somehow. Maybe the logic is confused.
C13, okay? There's nothing wrong with it.
No, lose that idea. Those are gross assumptions when you don't have proof. What I did see was this. Sometimes the deck would behave when it was disturbed. Who does that sound like? Touch an IC with the probe and it behaves. Pull the probe away, rewind comes back. Now that doesn't prove the IC is failing, it proves the whole circuit is problematic. And that's a tell. Then I hit another weird cause and effect. I hit the tape counter 0 and the deck behaves. And for a moment, I wanted to believe I solved it. But it wasn't fixed. Not really. So I did the ugly stuff. I cleaned pins, douched and scrubbed the board, including the sockets. Cleaning pins is a great idea. Cleaning sockets is an even better idea. But even then, I'm not comfortable that it's fixed. It just started working right, temporarily. Nonetheless, I moved on. I aligned it. I calibrated it. Everything looked good. Check out our next episode. But then it returned from the field, stuck in rewind. Down the rabbit hole I go again. So we did the smartest test we could figure out at that point. I borrowed a logic board from another 80-8. We have a few. Different revision, same connectors. I plugged it into this machine and it worked. Couldn't make it fail. Everything else controlled by that board was fine. So, reinstall the original board, knowing the integrity of the original board and its many connections were suspect. That's when the LED section revealed a different issue. They flickered. So the LEDs weren't bad, they were dim because the power supply connector was intermittent. LEDs are usually the first indicator of a bigger problem, and that was a clue. Anytime I touched the low voltage connector, the LEDs came back to life. That tells me it's a physical failure and hints where to look next. This wasn't an LED issue. Hell, it wasn't even a logic issue. It was a physical failure causing an electrical problem. This was an issue that showed up at the LEDs and pointed to the possibility that TTL logic was affected. The power pins are riveted through the board first, at manufacture, then soldered. What I found was oxidation on the supply pins. The pins were loose and signs of arcing, even though it's low voltage. Loose is loose. I could make it fail just by stressing the connector. That connector has 4 pins. 2 of them feed the logic ICs and LEDs on one end of the board, and the other 2 feed the control logic side on the other end of the board. So here's what actually fixed it, and this part really matters. Everything we did fixed it. Every element to this repair helped get the deck to behave. First, I reseated the pins properly. Second, I cleaned the pins on the ICs. Third, I modified and reinforced the power supply connector with bus wire to the circuit traces on the logic board. Fourth, I cleaned the sockets themselves. And now here's the thing I also discovered. The socket contacts themselves, that little metal V shaped that the IC pin sits in, okay, is fatigued. The metal is deformed. It doesn't grip the pins the way it's supposed to. That means even a perfectly clean pin and its socket can still have a bad connection. In a perfect world, the right fix would be to replace the sockets. But on these logic board, the traces are fragile. And I'm not going to really recommend that to just anyone. It's meticulous work.
Process of desoldering this right here took part of the pad with it. This lead is going to have to be bent over and actually soldered to this point here because there's no solder pad left.
Instead, I used a hook and pick to gently reform the socket pins for better contact. That was enough to restore reliable contact with the IC chips. Once those connections were solid, the deck stopped misbehaving. Go figure. No forced rewind, no dim LEDs, that's dim, not damn. And that's when we could finally move forward and actually feel a little more comfortable doing so. This episode wasn't just about being stuck in rewind. It was about what happens when a machine almost works, what's called intermittent failure, and why, when that happens, solutions can be elusive and the hardest to solve. What remedied the issue wasn't one particular moment of inspiration or one singular diagnosis. The totality of the process is what brought this particular machine to fruition. Paying close attention to the tells, regardless of their apparent insignificance. Chasing the things that don't quite make sense. Letting the machine show you what's actually wrong instead of what you want to be wrong. It's not glamorous work, but it is rewarding, especially when you remove yourself from the equation and let the facts speak for themselves. And if you're dealing with something similar, remember, one symptom could have multiple solutions. Let the failure do the talking and your fingers do the walking. Thanks for sticking with us, and we'll see you in the next one.